Aflasi,
Present, Miss.
Ajmina, Amaya,
Present, Miss.
Atulya, Drishya,
Present, Miss.
Jyotish,
Present, Miss.
Karthik,
Present, Miss.
Kavya,
Present, Miss.
Nachiket,
Present, Miss.
Neeraj,
Present, Miss.
Rangit,
Present, Miss.
Vaishna,
Present, Miss.
Vaishnav,
Present, Miss.
Anjali,
Present, Miss.
Shruti. Okay. Now, in the last class, what we have discussed is we were dealing with the data format of the IPv6 and the IPv4 protocols. Internet protocol, that is IPv4 and IPv6. We have studied what is the datagram format in both the cases. Now, today we will be just seeing the topic address mapping. Address mapping. So when I was discussing in the first module, I have just told a brief idea about address mapping. I don't know how many of you are remembering that or not. Okay, anyway, let me have a discussion on address mapping in today's class. As you all know, when you are considering an inter-network, it is nothing but it is a combination of many physical networks. Now, all these physical networks, they are connected by the inter-networking devices. Inter-networking devices in the sense you are making use of routers to connect all these physical networks. Okay, so suppose if you want to transmit or pass a packet from your source host to destination host, you want to travel or you have to pass through these different physical networks in order to reach the destination. Understanding? If I want to transfer a packet and if the destination does not belong to the same network, you have to cross through many physical networks. And then only finally you can reach the destination. So the host as well as the routers at the network level, they are identified by their logical addresses. Logical addresses is also called it as IP address. So at network level, you require the IP address. Now at the physical level, if you want to identify the host or the routers, they are recognized by their physical addresses. I have just told two types of addresses. One is the physical address and the other one is the logical address. Right? Now, if you want to pass or if you want to deliver a packet from the source host to the destination host, these two levels of addressing schemes are required. The physical addressing scheme as well as the logical addresses. So you need some protocol in order to map these physical to logical and logical to physical. And that is nothing but that process that is called it as address mapping. Understanding? I have told you have when you want to transfer a packet from your source host to destination host, it is not compulsory that the destination belongs to the same network. It may connected through, the packet has to go through several physical networks. Now, all these physical networks, they are connected by means of some inter-networking devices called it as routers. Later, you will be studying about routers, gateways, etc. Okay, so two types of addressing schemes are required in this case. One is the logical address and the other one is the physical address. Okay, now suppose your computer wants to send some data to the target computer. Now how your computers will be connected? Both the computers, they will be connected through a switch through an Ethernet cable, right? Just imagine you have a source computer, you have the destination computer, and you are connecting through a switch and via a Ethernet cable. Now, if you want to send the data, the source must know the physical address of the receiver or the Ethernet address of the receiver or the MAC address of the receiver. I have told three addresses, three names. One is the Ethernet address or the physical address or the MAC address. Both the three remains the same. So if you want to transfer a packet, the source must know the physical address of the target device. But the source only knows the IP address of the target. It is not knowing the MAC address or the physical address of the receiver. So you are making use of some protocols. Now, the two types of protocols, if you want to map logical to physical and physical to logical addressing, is nothing but the address resolution protocols and the reverse address resolution protocol. If you want to obtain physical addresses by knowing the logical addresses, you are making use of this ARP protocol. Okay, so ARP Address Resolution Protocol, it helps to obtain the MAC address or the physical address of your target computer so that the source can send data from the transmitting side to the receiving side. Okay, understanding what is ARP? ARP is nothing but it is the Address Resolution Protocol. What is it, how it works is, it is obtaining, you are getting the MAC address of the receiver or the target computer using this protocol. Okay, now, so I told when you are connected, when both devices are transferring the packets, the packet, you can call it as IP datagram. You want to send it to another host or router. So what the source has is only the logical address. It has only the logical address of the receiver. It is not having the physical address of the receiver. Okay, now, so if you want to transfer it, from the network layer, it has to be transmitted to the data link layer. Now, the data link layer, that data is, you can call it as a frame. So whatever is the packet or the at network layer, you will be calling it as the packet. And when you are transferring it to the data link layer, you are calling it as a frame. So the datagram, the IP datagram must be encapsulated in a frame so that it is able to pass through the physical network. So if you want to pass it through the physical network, you require the physical address of the receiver. Okay, so what the host will do is, you can see it in the diagram, the host or the router, they send a request packet. That request packet is called it as ARP query packet or the ARP request packet. Now, what does that packet include? Now, this packet includes the physical address as well as the IP address of the sender and the IP address of the receiver. Understanding? The host, whoever wants to transmit the data, they are having what is in that packet is, you are having the IP address as well as the physical address of the sender and only the IP address of the receiver. The sender is not knowing the physical address of the receiver. So the request packet is broadcasted. The query is broadcasted over the network. So whichever host or the routers that is connected to the network, they receives this packet and they will process that. Okay, so receives and they will process the query packet. But the only recipient or the only receiver who recognize its IP address will respond to that. Okay, now what they will do is they will be sending the reply packet or the response packet. Now, what does the packet contain? Response packet contains. So the response packet, it contains the recipient IP address and the physical address. Okay, so what the packet contains is the physical address as well as the IP address of the receiver. So what it is done is, the reply is sent in a unicast manner. Unicast means one-to-one. Only the intended device is replying to that message, right? But the transmission, I mean, the request was a broadcast manner, so that all the hosts in the network gets that request. Now, whoever is having the similar IP address, they will respond to that, and they will respond with a reply message. And finally, the physical address is obtained by the host. Understanding how the ARP operation is? Yes or no? Yes or no? Okay.
Yes, Miss.
So this is about the ARP operations. I will tell once again the importance of address mapping. Address mapping is required if, suppose if you want to send a data from the source host to the destination host, you are passing through several networks, several physical networks. Okay, so if so, two type of addressing schemes are required in that, in order if you want to transfer it. So one is the IP address and the other one is the MAC address or the physical address. So when you are sending it, the source knows only the IP address of the receiver. It is not knowing the physical address. So this ARP protocol helps to obtain the physical address of the target computer. Now, how it is doing is, the source host, they will send an request packet. So whoever is connected to that network, they will get that request packet, and the corresponding the one who is having the same IP address. Now, what does that packet contains actually? The packet contains the physical address as well as the logical address of the source as well as the IP address of the receiver. So the IP address of the receiver is consisting in that packet. So whoever is knowing, okay, this IP address belongs to me, so I have to respond. So they will respond with a reply message. And that reply message, it consists of the physical address of the receiver. So that is how the ARP, how it functions. Okay, so the ARP request is a broadcast and the ARP reply is unicast. Okay, now you have got an ARP, what that contains, ARP packet. So when you are considering, this is the format of the ARP packet, you have got several fields in that. One is, the first field is the hardware type. Hardware type, it is nothing but it is a 16-bit field. It defines the type of the network on which this ARP is running. Okay, so the type of the network, what type of network you are using it, that is specified in that first 16-bit field. Now the second field is the protocol type. Second type is, this is also a 16-bit field which defines the protocol. Now the third field is the hardware length. Hardware length is nothing but what is the physical address, length of the physical address. That is 8 bits. Okay, now the next field is the protocol length. Protocol length means it defines the length of the logical address. What is the length of the logical address in bytes? Now the next field is the operation field. Operation field, it is a 16-bit field. It defines the type of the packet. What type of packet? Whether it is a request packet or whether it is a reply packet. Okay, now you have the sender hardware address. So sender hardware address means it is variable length. You can vary it. It is, what it defines is, it defines the physical address of the sender. Now you have the sender protocol address. Protocol address is nothing but the IP address of the sender. Then you have the target hardware address, that is defining the physical address of the target, and target protocol address is, it defines the logical address of the target. Okay, so this is the frame format. So depending upon the packet, the target physical address as well as the IP address is put in that packet. Okay, so this is how, this is the packet format of address resolution protocol. Now, how it is encapsulated is, at the data link layer, you will be calling it as a frame. So you are inbuilting. So ARP packet is encapsulated directly into the data link frame. You can just see in the diagram, you have different fields and the data, what it contains is the ARP request or the reply packets. Okay. Now you are having 4 cases where you will use this ARP protocol. The first one case is, suppose if your host want to send a packet to another host which belongs to the same network. You can just see in the diagram. So if your host has a packet to send to another host that belongs to the same network, you are using this ARP. Now the case 2, a host wants to send a packet to another host on another network. So if it is the data has been delivered to another network, means through the router only you can do that. So it must be first delivered to the router, right? Now case 3 is a router receives a packet to be sent to a host on another network. It must first be delivered to the appropriate router. Okay, so a router has received a packet. So it will check to which destination the packet has to transfer, whether you have to pass it through another router. In some cases, you have to do that. So it will check. It must be first delivered to the appropriate router. Now, the 4th case is the router receives a packet to be sent to a host on the same network. So these are the cases where this ARP protocol is used. Okay, so this is the first type of address mapping protocol, that is called it as this ARP Address Resolution Protocol. So ARP request is broadcast and ARP reply is unicast. Is it clear for you? What is the importance of address mapping and what is ARP protocol? Why is it used and how it works? Yes or no? So that only we can move to the next topic. So if I want to obtain the physical address of the receiver, I make use of this ARP protocol. Jyotish, understanding?
Yes.
Okay. Now, the next, okay, good. Now the next topic is, the next type of protocol is nothing but RARP. That is Reverse Address Resolution Protocol. Now, what is the importance of Reverse Address Resolution Protocol? Why do we need it? Now, how it is working? So you can see in the slide, I will tell what is the working procedure of this Reverse Address Resolution Protocol. Now, what is the similarity between this ARP and RARP is that both lies in the network layer of the TCP/IP model. Okay, so just imagine the TCP/IP protocol suite. You are having the network layer. In that, the main protocol is the IP protocol, and the supporting protocols are ARP, RARP, ICMP, IGMP, etc. Okay, so it is a companion to this IP protocol. Right? So this RARP and this ARP, they are lying in the network layer of the TCP/IP model. Now I told if a host wants to send or need to send an IP data to another host, 2 types of addressing are required. One is the logical address and the another one is the physical address. Okay, so I told about the ARP protocol. What is its importance? Now what is the importance of this RARP protocol? So RARP protocol is used only when the physical address of the host is provided. I don't know about the logical address. I know only the physical address of the host. So what this RARP will do is it retrieves the logical address of the host from the server. What the RARP protocol does is it retrieves the logical address of the host from the server. Now, how it is obtaining the IP address? That is what it is being shown in the diagram. Now, how does the RARP obtain the IP address from the server? Now just imagine you can see in the diagram, you are having an authorized server, you are having a center, etc. And many nodes will be connected. Now, suppose the sender does not know his IP address. I will tell in which case it is not knowing the IP address. I will send it in a minute. So just imagine the sender, it does not know the IP address. So what the sender will do at first, the sender will broadcast this RARP request packet or the query packet to all the hosts present in the network. So what the sender, as the first step, what the sender does is it will broadcast this RARP request packet to all the hosts which is connected to that network, right? Now this RARP request packet, what it contains is, it contains the physical address of the sender. In ARP, what does it contain was the physical address, logical address, and the logical address of the sender and the logical address of the receiver. But in RARP protocol, protocol, what that packet contains is the physical address of the sender. Okay, now this request packet, it is being processed by all the hosts connected to that network. But only the authorized host which can provide that service, that is RARP service, will respond to that ARP query packet. And they will respond with a response packet. So such host, whoever is giving that RARP services, such host, they are called as RARP server. Okay, so this authorized RARP server, they will reply directly to the requesting host with the response packet. Now, what does it contain? It contains the IP address of the sender, right? So that is how the sender is getting the IP address from the authorized server. Now, once it gets the IP address, it will be storing the IP address in its memory. Right? So RARP protocol, how does it work is, imagine initially the sender is not knowing its IP address. So what it will do is it will broadcast a query packet or a request packet to all the hosts connected to the network. So that what the packet contains is only the physical address of the sender. Now, the packet is processed by all the hosts, and only the host which can provide an RARP service will respond to that. And who is providing that? That host is called it as the RARP server. Right? And that server, they will reply directly with a response packet. Now that response packet, it contains the logical address for the sender. Right? Now, this RARP protocol, usually it is required for diskless computer. Diskless computer means which does not have a permanent storage. Diskless, the computer or the PC without disk drives, that is called it as diskless computer. So what they will do is in order to load its operating system, they do the network booting from the server. Okay, so a diskless computer, initially they does not know the logical address. They are not able to find its IP address because the IP address is kept in the computer's secondary storage. So when you switch on your PC, the operating system, they will find out its IP address and we will be able to start up. But if it is a diskless machine, it is not able to find its IP address. So how does this diskless machine determines its IP addresses? By making use of this RARP protocol. So it uses the physical address or the MAC address in order to obtain the IP address for the sender. Understanding what is the difference between ARP and RARP protocol? So RARP is used to obtain the logical address. Okay, it allows any host to obtain its IP address from the server. So usually it happens when you are starting your computer for the first time, which does not have a permanent storage, right? So these are the two types of address mapping protocols. One is the ARP protocol and another one is the RARP One is to obtain the physical address of the receiver, that is by the ARP protocol, and another one, RARP, is the one to obtain the logical address of the sender. That happens in the case of diskless machines. Understood these two terms? One is the ARP and the other one is RARP. How does it work? So if I want to obtain the address, what I will send is, I will send a packet, a query packet or a request packet. Now the request packet contains the details, whatever the sender knows. So they will be broadcasting that. So whoever is connected to that network, they will be obtaining that packet. Now they will check whether the service is to me, whether the request is to me or not, whether I can give the service for that. So if everything is matching, whoever can provide that service, they will respond to that packet. Now that response packet, it contains whatever is needed by the sender that is required in that response packet. Okay, understood the two types of address mapping protocol, that is ARP and RARP. Yes or no, Neeraj? Neeraj is there? Shruti? Yes, understood. What is ARP and RARP? Vaishnav?
Yes, miss.
Okay. Okay, so far we were discussing about the type of, the protocols that is present in the network layer of the TCP/IP model. The main protocol, we have already learned what is the datagram format of all these things. And today what we learned is the address mapping protocols, which is also present in the network layer of the TCP/IP protocols. So the two type of protocols are, one is ARP and another one is the reverse address resolution protocol. Right? Now, we will just move on to the next protocol, which is nothing but DHCP. DHCP. DHCP means Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol. Now, what is this? What is this DHCP protocol? Now, if you are booting up your laptop or PC, you want to connect it to the internet, right? Now you want to obtain, get a site address, and so initially you won't be able to directly connect to the website until and unless your laptop or PC is having an IP address. So imagine you are switching on your laptop. You don't have any configuration settings done in that. So you want to visit a site. You want to do the internet. You want to do the surfing. You want to visit some website. So initially, you won't be able to connect it to the website until and unless your PC or your laptop is having a logical address or IP address. The case is you have, so suppose you are writing a letter to your friend. You forgot to write the delivery address of your friends or the to address. Whether the letter will reach to your friend, yes or no? You have forgotten to write the to address in your letter, whether the letter will reach your friend's house. Will it reach or not?
No.
No. So you cannot receive a mail to your house without the delivery address. Similarly, your device, you won't be able to download a web page without an IP address. The meaning is you are not able to access the internet until your device is having an IP address. See the importance of IP addressing. You won't be able to connect it. You won't be able to access the internet until your device is having an IP address. Okay, so every computer or a device on a network, they should have an IP address for communication purposes. So IP address is acting as an identifier for a computer or a piece or a device which is connected on a network. So to make the internet accessible, what is required is IP address needs to be assigned to your device. And that is done by the network administrator. And he can do it in two ways. Assigning of IP address can be done in two ways. One is manually you can do that, or automatically you can do that. Understanding? So there are two ways a computer can be assigned an IP address. One is manually you can do that, or automatically you can do that. So that is called it as statically or dynamically. That way is called it as it could be done either by a static IP address or a dynamic IP address. Now, what is this static IP address? Now, static IP is the way user is assigning the IP address to the computer manually. When you open your system, when you go to the network configuration, you want to go to the TCP IP properties and you are setting it. The user is setting the IP address manually to your device. That is nothing. That way of addressing is static IP addressing. Understanding? Okay. So what I told is every computer, whenever it is or a device on a network, they require an IP address for communication purposes. So the IP address is acting as an identifier. So you can assign the IP address to your device in two ways. One is manually you can do that, or automatically you can do that. So manual, that is by means of that method, I mean that could be done by statically, or the other one is dynamically. So static IP or the logical address, how you are assigning is the user is typing the IP address or assigning the IP address in a manual manner, or you are just directly typing the IP address in the network configuration properties. Okay. Now, if you have, so suppose if you are considering a network, you are having 3 to 4 laptops that is being connected to our network, or host that is being connected to your network. So what the network administrator will do is they will go to every device and he will set the TCP IP properties or settings manually on each host. So setting TCP IP manually means in addition to the IP address, they are setting the subnet mask, they are setting the gateway, default gateway, DNS server, etc. When you are if you are working with your PC, you can just see when you are going to TCP IP settings, what are the fields that contains in that. You have an IP address, you have a subnet mask, you have a default gateway, and you have the DNS, etc. So see, the network administrator, if he is able to type all these IP address manually, that is called that way is called it as static IP address assignment. Okay. Now, what happens if more number of hosts are connected to the network? This I told in case of 3 or 5, maximum 5. So manually you can just set the thing and configure it and get the access. But what happens if more number of hosts if it is connected to the network? Is it practically possible for the network administrator to configure the TCP IP properties manually? Going to each device, suppose you have 500 devices connected to a network. Is it practically possible for a network administrator to assign the IP address manually? No. right? So instead of configuring it manually, what the network administrator will do is he will configure one special host. What he does is he will configure one special host, and that is providing the service. So they are providing the IP address in a leased manner. Whoever is connected to that network, a special host will be there, and that host will be running a service to lease the IP address to all the hosts that is connected on the network. So that special host is called as the DHCP server. Understanding? That special host who is providing the service to lease the IP address is called it as the DHCP server. So in your home, you are making your PC, you have a modem or a router in your case. So the router supports the DHCP, embedded DHCP server. Okay, so once you switch on your laptop, you are having communication with your router. So the router is acting as the DHCP server. So when a laptop with automatic IP settings is enabled, you can connect it to the internet. So what you are doing is you are setting up the TCP IP settings in automatic manner. Okay, and the DHCP server and the DHCP client, they are having the communication. Okay, so the laptop is running the DHCP protocol. So that is seen in the next diagram. So you have your laptop, which includes the DHCP protocol. You have the router, and you want to connect it to the internet, and this router is acting as the DHCP server. Okay, so automatically you are assigning the IP address, and that special host is called, who is providing that service is called it as the DHCP server. Understood? Again, I will just tell it in the next hour, 1 more hour I have got. I will just explain it in detail once more. So DHCP is Dynamic Host Configuration Protocol, and if you want to obtain the IP address to your device, you should have an IP address, and your server is providing that IP address. Understood this much? We have learned 3 protocols today. One is ARP, RARP, and DHCP. How it works and all that we will see it in the next hour. Is it okay? 3 protocols. Anjali? Anjali? Understood what you learned today? Okay. So we will meet in the, I think you have a break now, right?
Yes.
Okay.
Yes, Miss.
Okay, go for the break. We will just meet in the 5th hour. Thank you.
Thank you, ma'am.